Hello guys. This is a video where we're going to talk some about this number system. So I am going to suggest that you draw something like this on your paper, and then make sure that you label each of them because you are going to need to know how to classify these types of numbers. It is going to be helpful to have a visual because we are going to do some more practice with this in class on Thursday. You just want to make sure that you have it written down so you kind of know where everything belongs and how they all fit together. I'm going to use one of my fun analogies to help you understand kind of what's going on. So with the number system, we have two types of numbers. We have real numbers. Zoom in so I can write on this a little bit better. We have real numbers, which I know you're like, okay, Ms. Moore, what's real numbers? Like everything's real. Everything that we've talked about are real numbers. Well, real numbers are like you think, things that you've heard of before. -2, -1.11111 repeating forever, 0, 1, things like that. Those are real numbers. Things like pi, those are real numbers. Now, I mention real numbers because we've got to talk about this little tiny bubble down here off to the side that are called imaginary numbers, which is something different. That's most of what our lesson is going to be today, is these imaginary numbers. Now, I know you're like, okay, imaginary numbers are something that doesn't really exist, but they exist in the fact that we need to use them for things later on. We'll use them for some math, but we'll talk about how they happen with intercepts and such, and you will use them in future math classes as well. So imaginary numbers will always have a piece that has an I. So a lot of times it'll look something like this: 4 plus 2i. And this is the imaginary part, while this is the real part. So anything imaginary is anything with an I, and we're going to talk a lot more about that I later. I call these Santa Claus numbers because, like, we know that Santa Claus is a thing, but he doesn't really exist. He is imaginary. So I like to call imaginary numbers Santa Claus numbers. All right. Let's talk about how to remember the real number system. Trying to get this not all spun around. So we like to imagine that the number system is kind of like the club. And I know y'all are like, Miss Moore, we don't know nothing about the club. We're not old enough for that. You get what I'm talking about. It could be any kind of club, the elite club at the football program or something. I don't know. It's like the club. Everybody can get in the parking lot. Everybody can be a part of real numbers as long as you don't have that I. Santa Claus, he's not part of those real numbers. But those real numbers are then split up into two groups. So to get in the club, you got to be 18. So if you're not 18, you got to go over here to this little side baby club called irrational numbers. Now, irrational numbers, this will be where Miss Moore would live, not because she's not over 18, because we know she's a little crazy. Irrational numbers are something that can't be written in a fraction, something that can't be simplified down. When you do math enter on your calculator, it still gives you back that nutcase decimal. So irrational numbers are things like square root of 2, square root of 3, pi, things like that. Irrational numbers are decimals that do not end. They continue on without any type of pattern. Now, the next thing we're going to talk about, so we had irrational, so we're going to talk about rational numbers. Ooh, my green does not look good on there. Okay, here we go. So you were over 18, so you were allowed to get into the club. So, you're on the outskirts of the club trying to see what's going on. So those are our rational numbers. Now you're like, okay, rational numbers. Well, irrational couldn't be written as a fraction. So rational numbers can be written as a fraction. So anything that you could transform into a fraction. So like 0.5, because that could be a half. 0.3 repeating, because that would be like a third. Any even whole numbers, 1, that can be in there. Anything like that, 0, any of the negatives, -1, anything that can be written as a fraction. And remember, whole numbers can be written as a fraction as long as we put a 1 underneath them. Well, now that you've been around the outskirts of the club, you've kind of figured out what you want to do. So now you're going to go in on the dance floor. Your song came on the DJ played your song and you are ready to go. So now you've gotten a little bit more in the inner circle. we have integers. Now, integers, that's that little bit more, they're a little bit more exclusive. Integers are things that you see on the number line. So like -2, -1, 0, 1, 2, 3, blah, 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 all the way down and all the way up. So they have to have no decimal part to them, and it would be something that you would put on a normal number line. Well, now that you're on the, the dance floor and you're getting your groove on, they see you and they're like, oh, she's doing real good. We like her. We're going to invite her in the VIP. So now those whole numbers are the VIP. Those whole numbers, they're those VIP people. They're those people you see, you're like, oh, look at them up there being fancy in the little top parts of the club, hanging out, whatever. Whole numbers are basically the zero and positive side of the number line. So 0, 1, 2, 3, and so on and so forth. Whole numbers start with 0 and then go up from there. And the last and the most exclusive part, the thing you don't even know about, that exclusive super, super VIP, you get to go be the guest DJ up in the club, is the natural numbers. And you're like, okay, natural numbers. That sounds kind of reasonable. Natural numbers are what you naturally start counting with. When you first start teaching your little tiny niece or nephew how to count, the numbers they start with 1, 2, 3, 4, and so on from there. So when we're going to talk about classifying some numbers in class on Thursday, what you always got to look for is what is the innermost circle that it can get to, and then we have to work our way out. So if I gave you a number like 5, you got to find the innermost circle. What's the innermost part of the VIP section that 5 gets to go to? Well, 5 is a natural number. So 5 is going to start on the inside. It's going to be in here. And it also, since it's also a natural number, well, that's inside of the whole numbers. So it's going to be natural. It's going to be whole. And then whole numbers is inside of integers. So it's an integer. And integers is inside of rational. So it's rational. And rational is inside of real. So it is all these things. And I know you're like, dang, 5 is important. It's got a lot of things about it, right? It was that super number 1 VIP, guest DJ and such up in here. So that is what we're going to talk about with identifying these numbers. That's why having this chart is very, very important. You're going to want to make sure you have this written down and you have this available to you anytime you are looking at these types of numbers. All right, on to the next thing where we talk a lot more about imaginary. So using what we've learned so far in our class, how would we solve for this equation? Well, I would minus 12 on both sides. 3x squared equals negative 12, and we'll divide by 3. So then I get that x squared equals negative 4. Well, if x squared equals negative 4, and I need to get x by itself, I need to undo that, so I got a square root of OMG. I can't take the square root of a negative. And the reason is because negative, anything, like there is nothing that you can do times itself to get you a negative answer. Like a negative times a negative is a positive, and a positive times a positive is a positive. So imaginary numbers are represented as I. Should have left myself a little space here. So they're represented as I. So what we would do here is we would get that x equals plus or minus 2I. The reason we have to have that plus or minus there is because negative 2 times 2, negative 2 is positive 4, and positive 2 times positive 2 is positive 4. And we're going to talk about what that I kind of represents here in a second on the bottom part of this page. So what we have to do is we have to actually break that negative root of negative 4 up into 2 different pieces. Square root of negative 1 and square root of 4. So the square root of 4 is where we get that plus or minus 2. But the square root of negative 1 is something that we can't really do. So it's imaginary. So that's where the I portion comes from. But the way you will see this written is plus or minus 2I. We're going to talk a lot more about plus or minus when we get into the quadratic formula as well. Using what we've done in class with simplifying radicals, first thing we always want to do here is take out that negative 1. So we have 3. Then you want to try to break down your factor tree as much as you can. So we can't break down 3 anymore. But what we can do is we can take that negative 1 and it becomes I. So when we simplify this, we don't have any pairs because remember, since there's An index of 2, you're looking for pairs. We don't have any. So we can write that I in front, though, to take out the negative, and we're left with square root of 3. All right, number 2, draw that out. -1 and 8. Can split 8 up into 4 and 2, and 4 is 2 and 2. And so still has an index of 2, so I need a pair. So and this -1 is going to become I. So we get 2I root 2. And these really should have a plus or minus in front of them. We're going to talk a lot more about that when we get back from spring break, when we talk about the quadratic formula. Okay, so let's look at number 3. Got to break down this -12. So we have -1 and 12. Break down 12. It's 4 and 3. 4 is 2 and 2. Your index here is still 2. And you're like, okay, what do I do with that -2 on the outside? Well, that's just something we end up having to multiply by as well. So what we want to do is still circle our pairs. We have a pair of 2s. So, and then this -1 is I. So I have -2 that was already on the outside times I times this pair of 2s that I got down here. And then what's left in the radical? The only thing that was not circled is the 3. So then we can simplify that. So it's -4I root 3. All right, let's look at number 4. Break down this -16, -1 and 16. Break down 16 into 4 and 4. Break down 4, 2 and 2. So then don't forget, we need to circle our pairs. Pair of 2s, a pair of 2s. And then this is I. So you had the 2 that was already out front times the I. And then we had the first pair of 2s and the second pair of 2s. And there's nothing left to stay inside our radical because everything got circled. So 2 times 2 times 2 is 8. And that is our final answer. All right, we have Maggie Simpson here, and she is yelling about some powers of I. So I do want you to make sure that you have this written down on your paper. If you need to pause it to write it down, please do. You're going to want to write this. This is what we call the I cycle. And I know that sounds funny, but it's called the I cycle because it actually goes kind of in a round. All right, so I to the first power is just I because I is the square root of -1. Well, if we square both sides, if we have I squared and we have -1, the square root of -1 squared, that squared actually gets rid of the square root, so it equals -1. Well, then I to the third is basically I squared times I, right? Because you can add up the 1 and the 2 and get the 3. So then I squared was -1, and regular I is just I, so then that gives me -I. And the last one, I to the fourth, is I squared times I squared, or you can do it the third and the first, whatever one you want, which gives you -1 times -1, which gives you +1. And that's why this works. It's more one of those things. It's just easier to go ahead and write it down and have it readily available to you when you need it. The one we will actually use the most is this I squared right here. We're going to use it a little bit today with some mathematical operations. Okay, so knowing that, I'm telling you right now that I actually goes in a circle. So when you go to I to the fifth, so if I'm looking at I to the fifth, I can write I to the fifth as I to the fourth times I to the first. Well, I to the fourth was 1, and I to the first is just I. So I to the fifth is also I. Same thing with I to the sixth. So with I to the sixth, it can be I to the fourth times I squared. I to the fourth is 1. I squared is -1. So 1 times -1 is -1. So it repeats itself. That's why we call it the I cycle, because it goes through a cycle and repeats itself. So after 4, we can just start by counting over again at the top. So a lot of students like to write this on their paper, and then if they're trying to get like I to the 10, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I to the 10th is -1. Make sense? If we have questions, we are going to talk about this Thursday in class. This is what I was showing you on the number system on the very beginning. We have two pieces of your standard form for these. You have a real piece, which is right here, and an imaginary piece. So the real number should always be in front. So if it's like 3 plus 2i, the real number should always be in front and the imaginary part should always be behind. That's the way you always want to write these. That is the standard form. That is the way they should always be done. Next, we're going to talk about additive inverse. Additive inverse is what makes it go to 0. So you want to take the opposite sign of each piece. Opposite of +2 is -2. Opposite of +5i is -5i. Opposite of -3i is +3i. Opposite of +43 is -43. Opposite of -7i is +7i. So this is something that's kind of easy once you see it. It sounds complex. It's not. Now we're going to do a little bit of work with I and polynomials. And it has all the same rules as before. You can only combine like terms. So things with I are like terms. Things without the I are not. The only thing is you cannot leave I to any power. So if you have I squared, you have to simplify it. So we're always going to write on the top of our paper, I squared equals -1 to remind ourselves. All right, like I said, at the top of our paper, we want to write I squared equals -1 so that if we have it, we know to use it. Here, we're adding, so we can just drop the parentheses and write everything that we have. And then we can combine our like terms. These whole numbers are like. 5 and -2 gives me 3. 7i and 16i gives me 13i. Make sure the whole number, the real number, is always in the front, and the part with I is always at the back. Now here with B, it is actually subtraction. So we have to distribute that negative sign. So it's 6, -3i, -10, plus 6i. We have to combine the real parts first. 6 and -10 is -4. -3i and +6i is +3i. So you want to make sure you're combining those like terms. Here, yet again, we want to write I squared equals -1 at the top of our paper, just to make sure if we need it, we have it. All right, here we're multiplying. And remember, with multiplying, you either need to use foil or box or whatever you want to do. But here, they don't actually have any pieces to them. They're just straight multiplying. 3 times -2 is -6. I times I is I squared. But what do we say? I squared equals -1. So what we're going to do is replace that I squared with -1. And then we're going to simplify. -6 times -1 is +6. All right, D, this is the kind where you can use the box method or you can use the distributive method, whichever one you prefer. Either one, I'll show both. So we can use this and we can multiply. 2 times -3 is -6. 3i times -3 is -9i. 2 times 5i is 10i. 3i times 5i is 15i squared. All right, we're going to have to get rid of that I squared, but that's okay. We'll deal with that in a second. So now we want to look at our like terms and combine them. So I've got -6 plus I plus 15I squared. Now remember, we cannot leave that I squared there. We have to actually simplify that. So remember, the I squared is -1. So I'm going to sub that in. Then almost last step. Have to combine that. So -6 plus I minus 15. And now these are actually like terms. That's -6 and -15. So what I need to do is I need to combine them. So -15 and -6 gives me -21 plus I. Remember, no matter what, that real number, that whole number, has to go in the front, has to be written first. All right, hopefully this is getting easy. I'm going to show you the next two when they come up on the screen. Pause the video and try them. See how you do once you push play and check my work. Go ahead and pause it and try these. All right, hopefully you did that. So I am going to use distributive method on this one. So I have 6 minus 9i plus 14i minus 21i squared. So I can combine these. 6 plus 5i minus 21i squared. I squared is -1, so I'm going to substitute that in. So then I can simplify that. Then last step, I can combine the 21 and the 6. So 21 plus 6 is 27 plus 5i. You'll notice I write my I kind of with a curve, and that's just to make sure that you see that it's an I and not a 1. That's one thing that students sometimes have trouble with. Okay, last one. It has that squared, which means we write it twice. Get rid of that, just write it twice. So I'm going to use box method again on this one. Five times 5 is 25. 5 times -4i is -20i. -20i. 16i squared. Now, some of you may be able to say right here that this is 16 times -1, so it's -16. So then we can combine our like terms. We're going to combine these like terms as well. I'll pick a color over here. Kind of draw through that, didn't I? 25 minus 16 is 9. And -20i, -20i is -40i. So you can write that as 9 minus 40i as well. All right, hopefully this is making sense to you. Sorry this video went a little longer than planned. I didn't plan to cover as much in it, but I needed to get these things covered so that we can talk about them on Thursday. Don't forget Thursday's quiz review. Please try that quiz review if you have some time. And hopefully you did well on the PACT today. And I will see you guys in class on Thursday. Bye.